Hello there. Okay, let's start on this. We're making a fidget dial. Let's start by setting some parameters. I want to know the magnets. Magnet diameter, which I know is 5 millimeters. Hold on a second. I think I need to do this in the future. Export parameters from one. Actually, let's try it. Get a little sneak peek into some other projects. Okay, now let's do this. Change parameters. So I got all these parameters. This is from the Fidget slider. Let's export it. Okay, it's a CSV. Okay, cool. Let's put it somewhere. Okay. Now let's see what that looks like. Yeah. That basically just gave us a CSV. That's cool. Okay. Don't save that. Okay, now let's try this. In here, I don't want to do that. I want to do this. Let's import them from that file we just made. So let's not import that one because I already made it. Okay. That's cool. Okay. I'm going to do that starting now, forever. I'm going to make some base parameters that I'm going to just keep in CSVs and be able to import them. That's awesome. Because, I don't. Let's just go through first layer, corner radius. Don't care about that. Top, bottom thickness. What's that? Slider thickness. Wall thickness, part tolerance, line width, line height. Magnet thickness, slider length, don't need that. Golden ratio, slider width. Magnet diameter. Okay, cool. Now, we want the dial thickness should be dial thickness should be top bottom thickness plus magnet thickness plus part tolerance plus magnet thickness, not magnet thickness, what am I talking about? Top bottom thickness again. So basically we'll have a bottom layer, then okay, I'm going to change this in a second. Dial thickness. We probably want like, Let me think about this for a second. I think that's fine for now. We'll do something else in a minute. Okay. And then let's do cap thickness, which for now I just want to be wall thickness. No. Layer height times how many layers? I think I want to just arbitrarily make it 5 millimeters thick, because that will make it the whole thing together about like 15 thick, which I think is perfect. So we'll just do 5 right now. Goodbye. Okay. Okay, and then detent count quaint detent count. There are no units, and there's going to be 6 to start out. We might change that. That'll be how many like magnet stops there are around it. We can probably update that in the future. We want dial diameter, which I don't know. Let's just see. I'm just gonna arbitrarily say 50. Feels right. What else do I need? I need the post diameter, which I think I want to be like 10. Probably. I want it to be pretty sturdy. 10 feels fine. Okay. What else? anything else that I need? Let's see. This. Yeah, the we'll call it the float gap. This will be the distance between the layers when I want them to float. And we'll do that at like I think we started like 0.5 millimeter. Okay, I think that's fine for now. Okay, let's start by sketching it. Make it like this. We're gonna try to do this more the right way, and do a feature at a time. Okay. Post diameter plus part tolerance. Although, wait. Yeah, that's the total distance. So that's what I want. Okay, this will be our middle disk. Okay. We'll extrude that. So we do dial thickness. Okay. Now we're going to create a sketch. Now this is going to get a little more complicated. Honestly, I'm just kind of trying to remember how I designed it in the last one. And if I don't remember, I will go look at that model and remind myself. But I'll just try to do it for now. Till I do the curvature also. Okay. Had a curve, but it was based on. You know what? Forget it. I'm just. There's no reason not to look at this. I did all this work figuring out this nonsense geometry, and so I'm not going to waste it. Okay. So I know that this is equal to that. This is, yep, offset of part tolerance. This is magnet diameter. So we got That's part tolerance from the edge. Okay, that's good to know. Okay, so the bump is from the magnet, half of part tolerance in is where that is. Okay. Okay, now let's do this. Horizontal, vertical. Just kidding. That's not. I just even. Oh, maybe that is what I need. Yeah. Yeah, because then I have to offset it from there. So let's take this and make it coincident there, and then we do. I could just do an offset minus part tolerance. No. Here is not that distance of now 2-point arc from here to here. It's going to tangent there, make it a real line. It's equal with this. And then go distance from that point to that point is part tolerance. I realized I screwed this up. This is part tolerance divided by 2. There we go. Now that is the same geometry as this. Okay. Which is cool. Great news. So then these two, not that, this and this, we will mirror across this line. Nope. Across this line. Okay. Okay, now this, that's our magnet slot right there. And then I'll have a look at this fillet that we do here later. Something I haven't really experimented with much is exporting actual sketches or geometry from one project into another. So if I use these magnet slots probably even one more time, I'm going to look into sketching them in a project just to export them and then bring them in other projects so that they're consistent everywhere. But that's a future me problem. Okay, finish that sketch. Look at us, one feature at a time. Now we want to extrude this, and we want to do a the start is an offset of minus top bottom thickness, and then the extrude is a distance, which is magnet thickness plus part tolerance So that means that the bottom, top and bottom thickness should be identical, probably. I don't know, we'll check and see. Let's just inspect real quick. Here to here is 0.45, which is what we want. And then from here to here is 0.45, perfect. Look at us, we're already doing it. We're already doing great. Now we will do section on here minus disk thickness divided by 2, just so we can see into here. You can see that I just save like literally constantly. I just don't lose stuff. Okay, so we got that. Okay. Now let's look in here and see. Get out of here. Save this. I think it's probably this. Yeah, this first fillet. This first fillet, as the people say. Please. Could you find it in your heart to let me actually edit it, please? Thank you. Okay, it's just part tolerance. And that was used on, yeah, on the inside edge, those corners, and also on the outside, which this actually I think helped a lot for getting the magnet started. It also makes it so that when you run your finger along this edge, it makes it like feel smooth, bumpy, like a ripple. Okay, I think that's the last we need from this. I'll open it back up later if I need to. All right. Now. We're going to chamfer that. Not chamfer, fillet. Do part tolerance. That looks pretty nifty. This will have an even wider opening because it's on a curve instead of a straight line, and so this part is wider. It doesn't affect this opening at all, which is what actually snaps in. So doesn't actually matter for how much it will hold it. Actually, does anything? Does it matter? This, I think this is fine. Now, because we did this, so let's just expand this here, turn off our section. Okay. So in the last episode, I told you not to do a bunch of big sketches all at once. And this is why. Because now what I can do is I can go create a little pattern, a circular pattern, and then I can switch this from bodies to features, and I want to do the fillet and the extrusion. I want this to be identical. Select our axis, which could just be the center, but could also just like do like the outer edge or the outer cylinder perimeter or something. I'm just going to select the axis because it won't change. And now, let me turn this. Now we can do this, detent count. So that count is what is going to tell you just how many are around. Do it identical, hit OK, boom. just like that. Turn off the body like a doofus. Just like that, we got our magnets around. That, let me tell you, it's not gonna. That's not gonna be enough. They're too far apart. I think they're too far apart. So maybe it's fine. Maybe it doesn't matter. I don't know. We can just like do a test print and see. So now here's the advantage. I can go back to this. Not that. Thank goodness it didn't even work. I can go back to this sketch. I just edited this one sketch. If I change it, then it will update all of these automatically. Beautiful, amazing, incredible. Okay. Now, let's turn off the section. I want to do a chamfer on both of these, which is going to be first layer height. Normally I wait to the end to do this, but I'm about to copy this, so I want to do it now. Although yeah, just kidding. Don't actually want to do that. Okay, so what we're gonna do, we're gonna do a move copy. I'm gonna select the body, and then we're going to create a copy. We're gonna look like this, and we're gonna hit up and down. We want to move. Dial thickness plus our float cap. Puts us there. I just realized these bridges are probably going to be actually pretty bad. Hold on. I'll look back at that in a second. Well, I mean, there's barely a curve there. So basically what I'm looking at that could be a problem is when this gets bridged over, this edge is going to droop because it's not a straight line. So we could just, chop it off right across there, which realistically is going to be like barely noticeable. I don't know, let's try it real quick. Finish that sketch, and then what we're gonna do is do this. What we're gonna do is roll back right here. Then we turn our sketch on, and we add an extrude of this little sliver. Just do all, because we want to cut everything. Why is that? On both sides. There we go. Okay. maybe we should have done it after the fact. Okay. Hold up. Wait a minute. Okay. Let's do this again. Go back here. Now I want to create a sketch right here. Turn on my section. So that's actually what we want to cut. So then we finish that sketch. And now we do the same thing. We do this, we do an extrude, we do symmetric, and we do all. We hit OK. So now it meets perfectly with those curves and it bridges straight across. That also means when you're putting the magnet in, it will press down flat, which I think could be good. So here's the benefit. We can roll back forward now. And see, these aren't like that. And then we just go here. All we do, select this feature. Hit OK. Boom. Now they're all identical. I think I'm good with that. And realistically, those notches off don't like matter in terms of it feeling round. But I think they will help with the bridging, so we'll do it. Okay, now. Let's make a new sketch. The front, do it right here. Let us project this top surface. Okay. I don't care about all these little stuffs. Here's what I care about. I want to do this. I want to go like this. And then I want to do actually. Skip that out. I want to do, might as well just model it in here. It's going to be roughly like that or something. Let me do from here. Just kidding. Project that. No. That edge. That edge. Now, this and this are tangent. Okay. Okay. I'm deleting that. Let's try that again. Okay, that feels fine. Then we go from here over to like here. Okay, now I want to take this and I want to just for now I'm just gonna yeet it across here. Like that. Just for the sake of constraining it. What? Okay, let's try that again. We'll make these tangent. I'm going to make the distance between that and this is going to be cap thickness. Okay. Then we want the distance from here to here to be cap thickness divided by 2. I think I need another curve between here and here. So what I'll do, delete the coincident. and delete the tangent. So that means I can move this around. So I think I need an over curve, yeah. Convex, if you will. Because I want to then make this and this tangent, and then I want to make this and this tangent. Yeah. So I want this to be like what if I do cap divided by 3. That's pretty good. Okay, and then over here we got this curve, which I think I like it if this is just on here. I think I like that. Right there. Oh yeah, okay. Then let's just make this be the cap thickness. This and this should be coincident. And now it's fully constrained. So this is going to be 2.5 millimeters deep. Let me see how much that. What does that feel like? That seems. I think that's probably fine, and then it's going to be about 10 millimeters across, which I think that's fine. I think this is a good divot. Okay. So we got this. So now what we do is we turn this body back on. We can finish our sketch, and then we can do this, create, revolve. Axis is going to be the center here. And I'm really, this kind of like yo-yo-ish geometry. Which, you know, don't hate that. Got the finger divot. It's got this nice curve over this edge, and it's got a nice little kind of curve up before it divots down. Let's do a section on here. YZ face. I think about that. What is that? Performance issues, what do you mean? whatever. Okay. Now. There we go. I think the divot needs to be wider. Mm. 2.5. That looks, I mean, that looks better. That looks more proportional. Okay. Now, still think 6 is going to be too few, but we will try and see. I think I'm just going to extrude all these up now. Except I don't. It's going to be the best way. Probably just doing it like this. Do an extrude of symmetry on all. You know what? Forget this nonsense. Let's try this. Not at all what I wanted. What if I just straight up delete this? There we go here. 2 features, okay. Look at that, boom. I'm fine with the bridging over it. It doesn't need to be rounded off. like that. It'll bridge just fine. Hopefully. I think I want this edge to be a little more sharp. Like this just feels too tall. I want this to cut down faster. So let's fix it. Remove that. And we remove that. And then we can say what this and this are coincident. Oh, right. Because so this is just this and this coincident. This and this coincident. Here is cap thickness. Distance from here to here is cap thickness divided by 4. Why is this not? What's not defined? Here we go. Okay. I think I like that a lot better. Okay, now just for the sake of looking at it real quick. I'm not going to be able to just mirror it very easily. Okay, let's create the post now. Yeah, so we need an offset plane from here. It's going to be dial thickness divided by 2. Divided by 2, not S. Typing is hard. Okay, now we can't make a sketch on here. Sure. This is post. You can see that it's almost the same size, but not quite. Okay, I mean that's the sketch right there. Let me just extrude it, and I'll turn this on so we can see. So we're going to take it up to 2 objects right there, except it's going to be a new body. Okay, and then we create a mirror of that body, and the mirror plane is the bottom of itself. It's a join. Okay, that's gonna be our post. We'll mirror this in a second. So now I have to decide something, which is okay, that looks interesting. What I have to decide is how do I want this to lock into the caps? I mean, I could just use glue. I don't really want to do that. I thought it would just be using like 3 slot features basically. You push it in, then rotate it, and it snaps in place. I think that's probably fine. Okay, let's do it real quick. So, okay, turn this off for now on the top. Actually, yeah, I mean, it can be on the bottom surface. There should be wall thickness, maybe. Yeah, I think that's fine. So we go from here to here, and then we make this horizontal vertical, and then we can do that, and then we can take this and we can mirror it. So we can do this to that. Okay, so we got this is our locking. How big is 1.2 millimeters? Oh, small, but big enough to lock it in, I think. Okay, we'll sure. What? Sure, whatever. Okay, then we do minus wall thickness this. It's going to be a join, which is what we want. Then we'll fill it this, which will be, I guess, divided by 2. Is that what we want? I think that's what I want. Because, I mean, ideally you do like, but we can't do that. What if I do that, but I also do it there? I don't think we need it there. I think this is all we need right there. I think that's great. Okay. Okay, so we got a locking nub. Now we need to make the slot for it. So, turn this back on. Okay. Let's just look at the section of it. So so basically we're going to make a sketch here. Just kidding. We already have that sketch. Yeah. Why is that sketch not fully constrained? What do you mean? What about it isn't constrained? You idiots. Everything is constrained. Whatever, I don't care. Okay, turn that section off, turn this body off, turn this sketch on, turn on the extrude. Then we go boom, boom, boom. Then we go to object, to here. Cut it out. Okay, then we're going to do a push-pull of this and this and this of minus part. There we go. It's really lagging out. Flow. Okay, that works for me. Yeah, I'm good with that. I think that'll fit. Okay. I think I actually need to edit this sketch. Bodies are driving me crazy. Okay, because I want to do this, and I want to create a circular pattern. Select the center point. This should be cadence. Divide by 2. Do a circle here out to there, and this slot is going to be the slot. Okay, there's that. Turn these back on. Okay, let's turn our sketch back on. Actually, I want to turn the body off. So I wanted you to put it in and then rotate it clock so that it rotates this way. Okay. So turn this off. So then from here. This will extrude. Turn this body back on. We do minus wall thickness. Cut. Okay, so this is going to be printed face down, so turn our section back on. So it's going to print like this. So it'll just bridge this whole thing over top, which I think will work perfectly. With wall thickness divided by 2. Divided by 4. I think that's what I want. fine. Let's just add a section real quick to be able to look at this. I also want to flip it. Okay, before I do that, let's put this here. Okay, well that works. Please let me edit it. We also want to add that. Okay, we save that. Look back at here. Okay, then I need to make a little nubbin, if you will, for this to bump past, to lock it in. Basically, I want the nub to come exactly to there. So there's no tolerance, which means that it will just barely catch, I think. That's the plan. Okay, but where do I want to make that, actually? Turn off the post for a second. Turn on this section. Just kidding, this section. What's the best way to do this? I think the best way is just create a sketch here. Turn on this sketch. Okay, so this is the end right there. So it's right. It's like that. This line. Okay. Turn off the body. Look back at the sketch. Okay, so it's like right here. That's basically what I want to do. So I want to make I want to project this tangent to there. And which is tangent to here. And which goes like, do I want a tangent? What if it's not? What if we change this to then do tangent constraint, delete that. What if we instead make this consider there? That means the distance, what is this? That's the part tolerance across. This means that this distance is half of the part tolerance, which is nothing. 0.15 millimeters. Okay. Now we're going to do what we did here. Basically, also I make this to be, please. Okay. Now we do a 3-point arc from right there to right there. That can be a 10. What? Hot diggity dog. This and this can be tangent, and then this and this can be coincident. We do the same thing over here. 3-point arc. Tangent. This and this are tangent. And this are coincident. Actually, I don't want that. This side is maybe fine. I think what if we make these equal? No. What if I make these equal? What do you mean? What do you mean? This and this equal. There we go. I mean, I'm okay with that. That's definitely what I want on this side. So I don't know what the heck happened there. Okay, I'm just starting. Okay, do this. Do this. Tangent there. This line R. Tangent. And this are equal. So that gives it a ramp up. I don't want to make it even steeper. What if I do this? What if I make these equal? No. It says no. You say no. Well, this and this. That doesn't have any real practical benefit, I don't think. So we'll just do this and this. Make these equal. That's fine. And then this side we'll do and this. Undo that. 3-point arc. Tangent. Tangent. Equal. That'll be our locking nub. I think that's fine. We want to extrude this. We want to turn that off and then turn this body on. Okay, we want to go to object. And we want to go to that face right there. And yes, we want to join. Fusion, please stop. Please get it together. Okay. Do that join. Okay, so now let's look at this section right here. Turn this body back on. So this is our locking mechanism right there. The pin, you rotate it, it goes, barely makes it over there and snaps in. I think I'm happy with that. And because this is going to be printed vertically. Oh, it's going to be printed vertically. Does that matter? I don't think that matters. I think that's fine. Okay, so we did that now. Now we save. And now we create a pattern of a circle. And we do features, and we want to pattern all the stuff we just did. We're going to pattern that, and this, and that, and that. Actually, no. Hold on. Let's not get too crazy. Turn off this body. Nope. This body. Z-axis. We want detent count divided by 2. Okay. So it's going to have 3 nubs like that. I think that's fine, and then the top ones are going to print upside down like this, which actually means that I kind of do want to do that. Otherwise they're going to droop down. Let's look back at that real quick. Just fill it. So if I do that, then it's going to build out here. I think these are, this is 1 point, hold on, hold up. This is a 1.2 millimeter overhang. Like that's literally, it's literally just nothing. So, okay, I'm just gonna do this for a second. Again, that's the benefit of doing the feature. I just, boom, now it's just everywhere. Let's look at here now. What is that gonna affect? That's going to affect this interfacing. Also, I realized this is going to need to have a press pull, because, or just adjusting the height of that, because otherwise it's not going to fit under it. That look with this section now. I think that's fine. Okay, so then this, this maybe, this. Wall thickness plus part. Nope. Minus. So now do this and we turn this back on. Could still put like a tiny drop of glue just to lock it in permanently, but that should be fine. Okay, that's good. Now this, okay. So this has the 3 pins on it. Now we need to pattern our groove features, which is more stuff, but should be just as easy, I think. Circular pattern, features, we want to do that, and that, and that, and that. Okay, and then we go over this. We'll do it for detents divided by 2. 2. Why? I think it's because I did identical. Let's try that again. Okay, let me select the axis, and it's that axis. D10 counts divided by 2, and we will do them to adjust. There we go. Well, it ruined everything. How? So the alternative is to do it in more steps by doing stuff like, actually, I think I can get away with doing these two. Maybe. Oh, I could also just like circular pattern the faces. That's another thing you can do. Let's see if let's see if this works real quick. Just like this, just like this. Axis. That D10s.
Hey.
Yeah. Okay, I think it's the offset faces that's the problem. So here's what we're gonna try. If I just do faces, there's a lot of faces. I don't know that this is a good idea really, but it's an idea. Okay, there's the faces we want to pattern. Then we select our axis, which is right here. That's what it's going to look like. Do D10s divided by 2. Please work. I mean, that looks like it worked. I really think I shouldn't have done D10s divided by 2. I think I need a no units. Okay. I want to do this because I want, when I want to change this, I don't want it to screw everything else up. So I need to do there should be lock pin count. Should also be lock pin count. And then in this sketch, that's not the sketch I want, it's this sketch, I think. Please. In the circular pattern, we want lock pin count times 2 times 2. This will do it, please. How? Why?
Dad,
Yeah.
can I do temporary tattoo markers?
Yeah, you can do a small one.
Dad, I know
Yes.
I'm not supposed to ask food. I know I'm not supposed to ask food. This is just a reminder, so you remember that we're gonna make root beer floats together.
I said we can probably do that later.
Okay.
In just a little bit after dinner,
Okay.
maybe we could play Mario Party together and then make root beer floats.
Okay, because I thought you, because it's been a while since you said that, so I didn't know if you had forgotten or not.
No, I did not forget.
And I really didn't want you to forget.
That's fine. I did not forget.
Okay.
Okay, love you.
Love you, Dad.
Love you too.
I'm building, you know the thing, that, I don't remember who gave it to me. Was it just me or was it Joy that got like the Safari Lego set?
Safari Lego set.
That's like the car and all the little people and the animals, the giraffe and zebra.
I don't really remember that one. I don't remember. I don't know who got that.
And you don't, do you remember what it is I'm talking about?
Not particularly.
Hold on. Just a second. Be right back. Here it is. Here's the box.
Oh yeah, I remember that one.
I'm building it.
Okay. I don't remember.
I'm almost done.
Okay.
It's only took me probably like an hour and a half an hour.
Okay. Good job.
It's really hard building it.
I know you'll get it.
Thanks, Dad. Love you.
Love you too. Did that mess anything up? That all looks fine. This looks fine. this is our locking mechanism. Spin and rotate it. And hopefully it snaps in. Yeah, it's fine. Okay, there's that. That looks fine. So now, so if I just mirror it, then they'll both have to turn the same direction. I want it to actually flip around. So I'm not going to mirror it. I'm going to copy it and flip it. So let's do that here in a second. First, I'm going to now redo my mirror of this body on its own plane. Join that. Put them together, rotate both of them, they snap into place. I think that's good. Okay. Turn this body back on. Here's how I think I'm going to do it. Going to do a move copy. Actually, is there anything else I want to do to this one? This first. Yeah. Okay, the whole top edge is good. I want to do a chamfer here of first layer. Because then it catches all of those as well, which is what we want. Okay. Now. Let's do a move copy of this, and we will create a copy. Okay, we want to flip it 180 degrees. Let's do point to point. What? Cancel. Okay, we want to move this body right here. We want to go point to point. And we want to select the okay. Now we can turn on this section. And see that is exactly where we want it. I guess this is kind of our first look at how it. So it'll be something like this. And then the middle edge I'm going to extend so it sticks out around it. How exactly I'm going to do that, I'm not sure. I don't know what I want to do about that. Figure that out in a minute. No, something. No. Okay, so this right here, you put it in, and then this pin rotates this way to lock, right? So you push it in, and it rotates clockwise to lock. Now, if we get this, the pin in, it rotates clockwise to lock. Yeah, okay. I just want to make sure. Okay. Go back to here. And then turn this off. Wait, what? Oh. That's right. This one. Oh. I don't actually probably need to do it beforehand, but I will just in case. First layer height. That would be good. Then we just roll it all the way forward. Why? Why did that mess something up? Oh, because the move is point to point. And that point don't point anymore. Just kidding. Why? What? Okay, top surface. Right there. Wants to go bottom surface of that right there. Okay. Let's save. It's been a minute since we saved. Okay. So now if we look at these. Okay. Let's rename some stuff. This is the dial. This is the top cap. Post. This is the bottom cap, which is identical to the top. It's just flipped over, so we're not actually going to export that. We'll just export the top cap, and so that'll be fine. Now we need to get rid of these. We're in here. I'm trying to think of how I want to extend this. I'm kind of thinking that I want to make it extend. I don't know about that. do want to extend it from here to here, basically. What's the best way to do that? What happens if I press pull this? Okay, let's try it.
Yeah. Is this a boy or a girl?
Let me see.
Here's its name.
Joa Puin?
Joa Puin. The two other ones are girls. I thought it was. Joy thought it was a boy. I don't know if it's a boy or a girl.
I think it's a girl.
Really?
I don't know. I think so.
Yeah, maybe.
I don't know.
It on the box. It looks a lot like a girl.
Okay. Well, then just do that then. Okay. I'm a little bit concerned that my computer's going to crash because my stuff keeps flickering. So I'm going to save this and start a new recording. Okay, now let's try to work on this again. Point. This can be the that's too much. This corner will chamfer and then what if I do 2 wall thickness? So it's 2.4. No, I think I like 1.2 actually. It's so thin though. It's two lines. It's gonna get slightly thicker from the ribbing on it and the ribs, so I think it'll be okay. And then take these, and then we do actually, so we're just gonna like press fit it on. From here to here. And this distance should be part tolerance divided by 2. No distance. vertical. And I want the distance to from here to here. To be part tolerance divided by 2. I think that's just what we're going to do. So then this is going to be weird, but maybe that's okay. Because I'm basically just going to just pop over there. What happens if I change this offset? Is it going to mess that up now?
Hey.
Hi.
So this chicken.
Okay. Create a revolve around. Okay. I'm going to turn that off now. First layer height. Okay. Oh. Didn't think that one through, did you, Noah? Okay. Well. Okay. All right. Let's roll back before we did that. And then okay, extrude. Nope. Distance is all both sides symmetric. Okay, that cuts that through there, which is good. Hit okay on that. Turn this off. Then we do the same press pull again. Which is part tolerance. 2. There we go. Okay. Now we can make a pattern, circular pattern of features of that and that. Select our axis, which is here. Quantity is the lock pin count. Do identical because I think we can get away with it here. Turn the post back on, and now we can see that we can actually put it together. But it'll still spin just fine. Now we can roll this back forward. A little chamfer there and chamfer those. That all looks good to go. Okay. That's fine. It's just gonna snap over it. We'll adjust the tolerances probably, but for now, that's just what it's gonna do. And I think that's fine. Okay. Let's turn that off. So here, sketch. And we're basically going to do the same thing here, where we take this, do this, we put one there, we put there, and then we're just making like really simple knurling. Tangent. This and this are equals. This diameter should be mirror over here. Okay. This I want to be construction. These do an extrude. 2 objects to the top here. Okay, join that. Okay. Because now we can do create a circular pattern of features, please. Thank you. Of this. Select that. So there's a calculator way to do this. So this is this is 3.14 times dial diameter divided by wall thickness times Okay, so it's a different way. Change parameters. Let's add. I think that's how you spell knurls. Let's ask Google. No E. Interesting. Okay, knurls, no unit. We'll just say 50 for now. Knurl width equals wall thickness. Is that the right thing that I want to do? Yeah, I guess. Is it ants or ants? Ants. Interesting. Okay. Dial circumference is 4 times dial diameter. Equals dial just make this 60 then. Okay. Okay, now we go back to our sketch. And instead of setting this, we delete that. We say from this point to that point should be our width. Wait, why? There we go. No. That feature, select the axis, which is here. Full identical knurls. Boom. Did it. Now, theoretically, I should be able to just change the parameter and it'll fix itself, but I kind of doubt the Fusion will do that. I'll try. So let's just say we want 75 knurls. It actually worked. What if I go up to, say, like 100? Okay, okay. See, this is why you use parameters and stuff. If I go up to 150. Those are getting pretty small. So that is... But I kind of like it. You know? I guess I could have checked. What does that make the knurl width is 1 millimeter. Those are really small. I think we do 125. What? Okay, let's make this 100. Nope. let's go with 75. Let's go to 100. What would be a good number? Do like, oh wait. If we do it as like 360 divided by d10ths times 2. Yeah, okay. 360 divided by d10ths times 2. Makes 120. I like that. That looks good. 0.3. Yeah. Cool. Why is this? What's messed up? Why? What's wrong with that though? What's wrong with the sketch? Please. Goodness gracious. Dimension from here to here, which is, why won't you do it? What if I just do this then? If I do distance from here to here. Okay. Let me do that. Seems fine. Okay. Oh, that's actually, yeah, that's what it's supposed to be. Okay, I like that. I could maybe see doing like a spiral knurling pattern on it, but I'm also fine with just this kind of knurling. Before we do that though, let us do, okay, don't target chain me. I want to just like, okay, what if I do this? Please, can I just, let's do a new body. Okay, and we can chamfer. Turn off this one. Do knurl width 12 by 2. Will that let me? Yeah. except I want to do distance and angle. Maybe this is not, in fact, what I want. I think what I want is actually a draft angle. So this, we want this, we want to, nope. Okay, we want a draft of Y. Let me make a draft, please. What does that mean? Why is it that I can't select this? Why can I? Why? Hold on. No target chain. I don't want that. What is the best way to do this? guess can I just move the face? I think what I'm just gonna have to do is turn the sketch on, not the sketch, this sketch, this sketch, this sketch, this sketch. And create a new sketch on this plane and project that line. Like that. Oh. That's probably why. First off, this drop off. So we do this and we do this and then we do that. Then we draw a line from there. Over to there. Then we do this and this. We could do 45. Or we could do more. Just kidding. Less. 35. Sure, why not? Let's just make a parameter for it. Is degrees, and we want it to be start with 35. That way we can just get rid of it. Okay. Now we will rock you. Do an extrude of that face, and we want to do all symmetric. And okay. Okay. That looks good. Now, turn this back on. We do a combine of this body into that body. We hit okay. Just kidding, undo that. A combine of this body and that body, because I want to keep the first one. Join bodies. Yeah, that's the ring. Okay, and now go back forward. And what we need to do is to have this also include that and that. And then we hit OK. Let it think for a sec. I think I should be able to manage this probably. Nope. What? Okay, we're gonna do adjust. Cool. I'll deal with that in a second. What if I fill this by knurl width divided by 2? I mean 3, 4. Does that make sense at all? Yeah, I mean, I think that makes sense. Okay, so we do that. Okay, now think about it. And please work. Cool. I mean, things it worked, but it clearly didn't. Okay, let's do faces. Come on, man. Okay, what if I do this? No, That's unnecessary. Let's think about how I could do this differently. That's what I thought. I'm totally okay with that. Now let's see if we can get this to work. This feature. Yeah. Create a pattern, circular pattern. Features are going to be this extrusion, that fillet, and that combine. Select this, select that. Do adjust. This is knurls. Or let's do. I prefer identical. Nope. Do faces. Come on, what is it mad about? Okay. Let's try again. This time I'm going to include the bottom. Not like any other faces there now. Come on, man. So why? Wait a second. Why can't I even select that? The heck? Are you kidding me, dude? Okay, what if I just do this? I really don't like this. How can you show me them and then you just can't create it? Okay, circular pattern of bodies. This body. Select the axis. This should be knurls. Okay. That works. Okay. Okay, save it. Save it. Okay, great. This is just what the geometry is going to be now. Because ain't no way I'm trying to do anything with this again. Because it's just going to lose its mind again. So. No, 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 no. I'm an idiot. Okay. Hold up. I did the wrong edge. No, no. Okay, well, let's do this. Roll back here. I literally can't believe I did that. I mean, the only way to fix it is to just... okay. The only way to do it is to just do it. I can't believe I just did that. I mean, I can't believe it, but doesn't make it less frustrating. Can we do that? Now we save again to make sure that I don't. Okay, that was a close one. No, okay. So that gives us a much better edge. This will be slightly chamfered, I think. You know, it looks kind of like a macaron, however the heck you say it. I don't know, man. All right, so now all that we should have to do is take this and we want to do a chamfer. radius of first layer height. So I have to think about it because all those things. It's probably not going to be happy with that. Yeah, didn't think so. So we'll just do it on the inside. That's fine. The outside is already basically chamfered. So now we take this and we do a mirror of this guy on plane of that. Let's join. We save. That, I mean, I think that looks pretty cool. Just nice divots. So the idea is you pinch the sides and you can like roll it on a desk or something, or just hold it and spin it like a fidget spinner or whatever. Eventually we'll cut like a triangle in it and put numbers on the inner dial and make it a dice maybe. That's what I'm thinking about. But those are bridges we'll burn when we get to them. Okay, so let's look at this. This one. Nope, not what I want. This one. I mean, these gaps look like a lot, but they're really not. They're like fractions of millimeters. I think we just try it. Let's think about if we're missing anything else, but I don't think so. No. All right.
The bedroom or the loft, please.
Okay, let's, I think I'm fine to just go ahead and get these exported, ready to print. Yeah, I think so. Let's get this and make sure. I think it should be fine. Okay. Let's try it. Let's do it. Okay. Let's start with the cap, I think. Okay, pull on 5. Initial is 3, line width is 6. 10. Wall line count is 2. Okay, so I think that'll bridge fine enough. I kind of want it to be concentric. Yeah, I'm not worried about that bridging like at all. Okay, it's gonna be solid. To 10, 70. Speed is 60 with 10 initial. Slower later is 6, which I don't think is actually what we want. Let's drop that to 4. How much time does that save us? 2 minutes. Okay. Yeah. Okay, no support. The adhesion is a skirt. Why is it doing it on a 3? doing that? Is it because the length? No. I just do 2. Does that change it? No. Not sure why it's doing that, but whatever. Don't care.
Dad said you have to go clean the room first. Put your shirt on and go clean the room.
Okay, cardboard plate. It seems fine to me. Okay. What the heck? I think for this one I probably ended up do print thin walls. Oh, it's because it's thin. That's why. I have a feeling that this is not going to print super well, but we'll see. May have to fix that. And then the last one is the post. Yeah, I think it's fine. All right, I'm gonna go print them and see what happens. Okay, let's try to fix some stuff. Actually, that's not what I want, it's this. That's what I want to fix. Nope, just kidding, not this. This sketch is what I want to fix. Okay, here's what I want to fix. Okay, here's what I want to do. I want to get this. Get rid of it. I want this to be part tolerance times 1.5, I think. Then I want here to here. I want that distance to be part tolerance divided by 2. Okay, just kidding, actually. This to be part tolerance. Of this, lift this up, this down, make the distance here to here be part tolerance 2. And then make this horizontal. Y. Uh-oh. Get rid of that. Now we make this horizontal. Because I mean, this is a 0.3 millimeter overhang, so that is fine. Is that what we want? I don't think so. I actually think we want to do that. And then make this tolerance divided by 2. Just like that. Times 2. We'll see how this thinks. Might cause problems. No? Okay. Cool. Okay, I think that's fine. I think on all of these I need to cut the part tolerance in half. It's a little bit looser than I want. But I think that fixes the outside. I think I might want to do just save real quick. I think for the knurls we want to do half as many or something. Times 2. Maybe go down to like times 1.5. Let's try that again. We can drop it down to 60. Okay, let's see if we can fix that. This distance is gonna be knurl width divided by 2. There you go. Okay, I think I like that better. I also think it's going to print better. Makes it a little bit chunkier, but I think that'll be nice. What's wrong with this now? Oh, because those bodies don't exist. That's why. That checks out. I think that actually makes for better flow. This kind of flows better into there. Feels nicer. This I think will do better. Okay. We might have to go all the way back here, which is a little scary because this needs to be less part tolerance divided by 2. Come on, you can do it. Maybe you can't. Okay, there's that. What is this offset? Oh, that's why. Turn off the cap. This needs to be more substantial. This needs to be more substantial. So let's do that. I feel like this is dangerous, but we'll try it. Oh, that's not actually what we want. It's this. Yeah, that's much more substantial. Did it just work with nothing breaking? That seems... I mean, that looks good. That also made these notches beefier. Okay, let's look at here. I just want to look at this sketch. Whoa. What? I don't know what happened here. Let's do this. Okay. Do a line from here to there, where this and this. And then this right here is going to be Hmm. .9. See what that looks like. I think that could work. I think okay, cool. Okay, now back here. make it thicker. That ain't what I wanted. think this solves a lot of our issues. Now I want to fix this. This gap is huge. Way too big. That is the flow gap. Yeah, 0.5 millimeter. Crazy. How about we do like... Okay. So that's fine. Okay. also want to change this. D10s. Hmm. Tile magnet count. No units. It's going to be 3. And this is cap. The cap magnet count should be 12. Okay, now. Change this to have that's what I thought. Please let me edit it. Tile magnet count. Now we create a circular pattern. We're gonna just do the faces. And we gotta make sure we get all the faces on the top one. Okay, then here we will do, okay, first gonna get our axis, which is that, and this will be cap, magnet count, Y. What? Oh. That would be why. Because I forgot to make it unitless. Okay. There's that now. Okay, everything seems happy, so that's cool. Yeah, this is definitely a macaroon. For sure. Okay, I think I'm just gonna go ahead and put 12 in it, and then what we can do is just not use all of them. You know? But now I can change these separately. So if I want more. Do that and then it's never there. Let's say we want 6 here. Should get rid of half of them. Boom. Cool. Switching it back to 12 though. Okay, let's turn this on. Let's look at this real quick. What? Oh. Wait a second, what? Okay, it's fine. I think this will work better. Is there anything else that I think I might need to adjust?
Daddy,
Yes.
can I play with your 3D printed stuff?
Which one? What ones? What do you mean?
All the ones.
Like what ones?
Like the ones that Evie painted.
Oh, like the shark and stuff?
Yeah.
Yeah, that's fine.
Where are they?
I don't know. You'll have to ask Evie. She had them. Hey, we're gonna finish. We're gonna finish math in just a few minutes, okay?
Okay.
Love you. still debating on this right here. So this is exactly flush with that. I'm a little bit banking on it over extruding, but I think it's fine. I think we try it, and we might have to. I think this is the most likely thing to adjust. Oh, that was what I was going to maybe do.
Dad, have you seen the 3D printed things?
No. I have not.
He said it was around here somewhere.
I'm just not sure. I'm not sure where they are. Hold up. Minus dial thickness divided by 2. Wait. Wait, what? Minus dial. Okay, that's what I wanted right there. This looks pretty cool. And I think you'll be able to make 2 of them and run them together, actually. Okay, that's right. That's why I did any of this. Because I wanted to look at this real quick. Because basically, I'm thinking that this is not going to just be friction. Is not going to be enough. I need actual indents. That's gonna just be a pain. Actually, it won't be that bad.
Right here. What? It was right here. Huh?
Didn't you put them away somewhere, like in the playroom when they were on the chair in the loft?
I remember that. It was
Remember
right here.
we were cleaning them up from the chair in the loft. And
Yeah, I put them here.
Weird. I don't know. Look in the playroom or something.
Maybe Mom put them in the playroom. But they're all...
Okay. do I want to do this? I think if we like bump out here. That is probably what we want. Where is this plane? Oh. Okay. Okay, here's how we do it. Go here. Draw a line there. Draw another line. Make a dimension from here to here. This will be 360 divided by dial magnet count. Divided by 2. So this means if we turn this section on. Okay, so then oh, this is because the chamfer. That's fine. I don't care.
The good news is, bum 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 bum. George done on the tail wag. Bad news is, bum 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 bum. Oh, we can't find the stuff. And the other good news is, bum 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 bum. I found Stacy, my robot.
Okay, cool. Sounds good.
But the only thing
You found Honda Tailwag, Joey?
yeah,
I haven't had her for a long time.
I haven't had my unicorn for a long time. I know, I haven't had her. That is crazy. How could you find on a tail whack?
I don't know. She looked around. All right, going out.
I can't find it. Sorry, Dad.
It's fine. I don't know where it is, but it'll show up eventually. Okay. Put that there. What are you doing? No.
Oh, the unicorn hairband.
What are you?
When are you going to fix the unicorn hairband?
I don't know when I have time to do it. When we get to all the other fixing stuff. Okay. So here, circle. We can exit there. Maybe we try it. That is, in fact, not what I want.
Dad, look what we found.
What is it? Ooh, the little pretend birdie. That's fun.
Where did you even get it?
I don't remember, honestly.
Why do you even have a pretend bird? Evie said.
No idea.
Evie said you would kill.
No, I didn't.
I
never said that.
Yeah,
I said I think he might be mad at me if
No,
the feathers were falling.
No, you said he would kill you
I
if the feathers will fall off.
Never at one point I would say that.
You just said it. You said it a little while ago.
No, I said.
You said it
All right,
2 minutes
all right,
ago.
all right, all right.
I said
There's no need to fight about it. I'm obviously not going to kill anybody about anything.
I know.
Oh, wait. Yeah, that's why.
Dad, I have a
Yes.
super duper special drawer that has secret stuff in it. Some stuff I'll let people see. Most of the stuff I'll let people see. Because most of the stuff I'm playing with often. But I haven't really gotten in there in a while. Sometimes Joy goes in and takes stuff out of it for us to play with. And I was just looking through it, seeing all the old stuff I had in there. I found it!
Oh, cool. The gold element.
I love my outfit. The outfit.
All right.
Wait, is this the same film that you made the coin with?
Yeah.
Wow.
Okay. Here and here, like that. Tangent, make this coincident with that. Okay, I think that's fine. this. We create a mirror over here. We make that construction. We make this construction. So we want this, 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 and that will be the bump. So then we use that to extrude, turn off our section, turn off, okay, then we chamfer this and this by first. Okay, then we circular pattern that. Features. And then we want it to be dial. Okay, dial right account. Just want to make sure I use the right parameter. Now what we can do. This one, you can see how it's overlapping now. Now what we can do is we can combine. We can do this target body, this tool body, keep the tool, cut it, we can turn the dial off, and we can see we've now got our indents around there. Probably doing a press pull is not a bad idea. But, because I mean, I'm a little bit concerned that this is just like, I'm not going to be able to put them together now. Start by saving. I'm a little bit concerned about this, so I think we make it a little smaller. Yeah, I actually think that will probably work fine now. Okay, now let us export it all. Come on, man. Okay, let's get these new versions resliced. We'll just go in order, I guess. Okay. This looks fine. Looks good. Yeah, the div in the top looks much better. So I think I want the, let's do like random. I think I'd rather do that. Okay. Save that. Clear the build plate. Then we do the dial. Oh, wait, hold up. I'm going to reslice that. The cap. Because I think the middle of my build plate is like losing adhesion, so I'm just gonna put it like, actually, I can see it better if it's over there anyway. Okay, save that. Version 1.1. Then we clear the build plate. go back to the cap again. And we're just gonna give it a little move Z over here. Just a little concerned that the middle of my build plate is like getting scuffed up enough where it's not adhering well. Okay. Now we did cap, did dial, now we do the knurl. Once again, I'm gonna move it. This one, I've been thinking about putting a brim on it because the first one really didn't stick down. I think the bigger knurl pattern will help it like a lot, but and also the bigger bottom surface. Maybe we just print it slower also. What's up?
Can you 3D print stuff without designing?
You could use your 3D printing pen.
No, I'm saying like make on your big computer without designing.
How would that work?
How
would it know what to do?
You look on here and scroll everywhere and push that one and push a button that says print it, and it'll print it. And then send it to your computer.
Yeah.
And to your printer.
Yeah, that doesn't exist. I can find a design that somebody else did. Somebody's got to design it. It's got to come from somewhere. It can't just print from nothing. You have to give it this. That's what the slicer's doing. It's just making a bunch of instructions. Look, you can even, if we do it this way, look, you can even see that is showing where the nozzle moves. This is just a bunch of instructions about where to have the nozzle move to print it. See that yellow?
Uh-huh.
That's showing you where the nozzle would be. And so each layer, you can go down, like we just go to this layer right here. And then this is showing you for this layer where the nozzle moves to print it.
Oh.
So
Well, can't you just easily find a design that someone else did to make my Lego man? Because I really want to do it now.
Maybe somebody else's Lego people are popular enough. Somebody else has probably already made it, but we'd have to look around and just see if we can find one.
Okay, I'm really excited. I cannot wait at all to do this.
Well, you're
Yeah,
gonna
because
have to have a little bit of patience,
because
but we can do it soon.
because the Lego girl is going to be Tina. Yeah. Right now we had an idea. Tina is just a spirit, and her body hasn't been built yet.
Okay, I mean that's fine.
And then the Lego person will be Tina, just built.
Okay.
This can get a little confusing.
All right. Let me finish this.
Try 3D print stuff on my pen.
Not right now.
But Dad.
Yes.
I want to fix my dragon. I just found my special drawer. That his wing broke.
Not right now.
Okay,
I can do it a little bit later.
Why can't I?
Because I just want to be able to focus on this for right now.
If did you know that is this small? Nope.
What are you talking about? You silly.
Well, why do I have to be in here to print it?
Because we don't want to make a bunch of messes other places.
I mean, like in front of this whole room, and now that there.
Not right now. Go, please.
You're this big.
Okay. Go on. I want to try to finish this. I'm gonna have to leave here soon. So go on out, please.
Once you're done with that, can we do so? Can I 3 print?
Yeah, that should be fine.
Okay.
Love you.
Me too. I also want to try making a tiny Tina with my pen. Tiny
Okay.
Tina. Ooh, what? I just got a great idea. What? Dad, can we borrow some cardstock?
You can't borrow it, but you can have it.
Okay. Dad, what's this? What's the bottom cardstock that just has a
Bottom cardstock.
what? There's another layer of there's another cardstock down here. That.
Hold on. The yellow package is cardstock, which is sticker paper. The white package is just normal printer paper.
What?
That's just normal paper. And
I
then
kn-
underneath it is sticker and label paper and stuff.
Huh?
Underneath it is there's label paper
We
and
haven't
the
had
vinyl
that.
sticker paper.
We
and
haven't
stuff.
had this like regular paper in a while.
I just Sarah helped me get a new package out. All right, go on.
Dad, is this super glue?
No, this feels like hot glue. Some kind of hot glue. What's that from?
I found it on the floor.
Okay, it looks like trash. Okay, go on.
Okay. See you, Dad.
See ya.
You
Right.
need the door open and closed.
Open. Rachel and TJ will be here in just a little bit.
What about Poppy?
I have no idea. I don't know if Poppy's gonna come or not. That's a question for Mama. I think these will be fine. So this, okay. So we've got the cap, the dial, the knurl, and the post. That's all we need. So let's try printing them all again and see if this version's better. Okay, let's make our adjustments. So first order of business is fix the float gap. I feel like we just don't need any of it. So that would be back here. You know, maybe it does need it. Let's do this. Minus flow gap. Minus flow gap. Divided by 2. Actually, let's just do minus flow gap. Okay, so that makes it so that there's no gap between them, which I think is fine. Because the tolerance on the posts causes a little bit of gap. Okay, let's look at our section analysis. So that got rid of the gaps here between the layers. So that tolerance is actually going to come from here. So between the actual pins in the slots. You can see there's a gap here. That gap ends up between, because this post gets pushed down, that leaves more room between them. So I think that's why it seems like there's too much space. So that's a good first fix. The other thing I was gonna fix is what? Oh, the knurling. Make this right now. I want it to come all the way up to to here. I think I also want to make this edge sharper, maybe. I'll think about it. I mean, it ends up a fairly sharp edge. We'll see. Okay, so let's go do there. Turn this off. Come on, let me edit it, please. That's not it. It's this. Yeah, that's it. Let's turn it though. Okay. Actually, I think we need to fix this curve first. Actually, nah. Okay, so we want to delete this constraint. So now we can move this up. Do we want it to go all the way to the top of that curve? I really want it to go like, we'll do this. Okay, we'll project that. And that we can go here. An easy way to get halfway is draw a line between them and then use the midpoint. Do that. And then we can make this and this coincident. I'll pull it up. So now that is going to be a little bit higher. I think I want to I'm going to change the chamfering over the edge here. I think. See what that does. Okay. Okay, that makes the ring much larger, which I definitely like. I think that's good. Let's look at it from the side. I want to change this. Origin. Select XZ plane. Flip it. Okay. Okay. Okay, I like the flow of that. I want this corner to be a little different. Really wish that could be rounded more, but I don't know that I can. I don't know that I can do that. So what it looks like on top should look pretty much the same. We can turn the origin back off. Let's save just in case. See, why are we getting this gap between it? Okay. Now let's look into what's this. That's fine. This. One second. Let's do a side profile also. Okay. Now. Go here. Did I really just do it backwards? I did. Okay, flip that. Now, go here. Please let me edit it. I think I make this a little bit smaller. Oh, that's just the knurl angle. Okay. Okay, so we do that. Turn off our section. And let's change the knurl angle. $35. Let's just go a little at a time. 30. So this should get steeper. Okay. Put this over here. Let's look at this and see how it looks. I think that's probably good. Yeah. So we can close that. Okay. Is there anything else I was going to do with this version? I want to try putting only 3 magnets in to see if it spins easier. See, I want it to spin like that easily. Right now it takes too much force. I think that's fine. Oh, I was gonna maybe make the pin have slightly less grab. So let's look at that. That's not it. It would be here maybe? No. The sketch. There you go. So right now this is really hard to get to snap past this and get it to stay straight. So I think I want this to be print tolerance times 2. It's just a tiny bit less, but I think that's gonna give it the right amount of snap for this to be able to get past. So what I'm concerned is that it's actually just bending this to the side and then getting jammed in there, but not actually snapping in, and that's why it's not holding properly. Okay, let's finish that sketch. Okay, that looks fine. So we've got our main post. Also, these little nubs. Oh yeah, that's what I was going to do. These indents into the knurling don't matter at all. Like this. That doesn't matter at all. Because they're not lining up on there anyway. So we can just delete that. And that'll be fine. Let me look at something real quick, actually. Okay, yeah. I mean, these barely stick out, and with the chamfers, they're able to just slide past and snap in. Okay, I think this is good. Save it. Okay, I got a couple final adjustments to make. First thing is I want to fix the locking pin. It is slightly looser than I want it to be, so if I get this, let's turn off the cap. Leave the post on for a second. Okay, so originally it was 2.5. I took it down to 2. We're doing 2.25. I think that'll be good. Finish the sketch. Okay. Let's look at this section and make sure it's looking good still. Yep, that looks fine. Okay, what else did I want to adjust? Okay, I want to adjust this to be like the height of here. I might want to make this less curved. That's what I'm thinking. So let's do that first. Where's my curvature of that? I think it's here. No. It's the first revolve. It's this revolve. Please let me just edit it. There you go. Okay. I think I want to delete that right there. Which lets me do that. Those two should be coincident. Here to here. Should be cap thickness times 0.25. No. Actually, maybe. What is this? Divided by 3. Times. %. Okay. Okay, that I think is going to be better. Yeah, I really could just make this a sharp corner, honestly. But I think this is actually fine like that. Okay, finish the sketch. I might have actually fixed this also. Hold up. That would be here. There you go. Okay, yeah. Yeah. Because that's based on the curve. That. Put this coincident here. think that's what I want. It's really much farther from the edge than it needs to be. If I throw it. Okay, that is what I want right there. Okay. This edge, I really just don't like it. But I also just don't know a better way of handling it. Okay, let's think about it. Actually, sorry, first I want to address this here. Go back here. Definitely helps keep it in line. Trying to think if there's a better way of handling that. I think I don't need this right here, actually. think that's fine. I think I might be going back to screw some stuff up. Okay, we're just going to save this here for a second. Oh, that's right, because there's a chamfer. The chamfer barely exists in reality. Okay, let's try to do something about this top edge. I want it to be smoother. That's the main thing I want. So that's all the way back here. So let's roll back there. See what we can do. So we've got this. We do distance and angle. The distance is going to be wall thickness divided by 2. What is this? See, that still leaves me with this crappy edge that I just don't like. I just don't think I like it. I don't think there's any way around it. It's like that isn't going to leave me with any better of an edge. There's still the sharp edge. Can I transfer it at this point? I mean, that's...
Dad,
Yes.
I spooked up on Joy and scared her, and then gave her some bath soap to play with, purple poopy soap. And guess what she did? She went, stop! I got to pee in the pool.
What?
I don't know why.
Okay.
Done with her bath.
Okay.
Are you ready to pick it and do it?
No, give me just a minute and then we can.
Okay. I either want something like dicey or Lego-y.
Okay. Well, we'll look at it and see.
Legos are the best.
They're very fun.
What if you made a house like this, exactly this size, but it was made out of Legos? What if I made a house this size out of Legos?
That would be crazy. I don't know that would be possible. But maybe.
Remember when you showed me a picture of you and Mom on your honeymoon, and you saw a Lego person made of tiny Legos and a rocket ship.
Yep.
Made of tiny Legos.
Yeah.
And it was huge.
Yeah, that's true.
That is hard. Making a whole house out of Legos, that's crazy.
Yeah.
There was a time that you went on the Noah's Ark ship, and I can't remember where, and you weren't even close to being the exact size of the door. Was that on your honeymoon with Mom also?
Yes.
I really want to go there. Nana said it was the best. It was the best tour she's ever been in. Did it actually have animals in it?
Not real animals, but they did have a petting zoo.
What's a petting zoo?
Like a small little section of animals that you can pet. You know, like they have at Appleworks.
Mhm.
Yeah.
I keep asking. We'll always go to Appleworks I keep asking, can I go on a pony ride? Can I go on a pony ride? And Mom will always say yes before I go there. And then once I get there, she says no.
Okay. Well.
I love going on pony rides and horses rides. I've always wanted to when I was a kid. I mean, as a kid and how I am right now.
All right.
As younger.
We'll be able to do that sometime. Okay, let's take this, make it coincident there.
Hey, I actually have to go pump, so
Okay,
can you just make sure they go to bed?
yes.
Thanks.
What is going on with that? Okay, now transfer this by first layer height. Maybe I don't want that. Oh, I hate that. I don't want it to come down lower, but we can deal with that in a second. Can I please edit this?
Done with the blankets and clothes and stuff.
Okay. Okay. I want the angle to be much sharper, so let's do that. So 30 degrees. Let's go down to like 25. That should bring this down farther. Let's go farther. Let's go 20. Okay, 20 is fine. Is that what I want? I don't know, man. Let's look back here. Okay. Why can't I see my coincident constraints? Why won't you tell me? Oh. Okay. Then we do distance from there to here is going to be the knurl width divided by 2. Let's see what that does. This don't target chain.
seahorse picture in our room.
Okay. Have her try to fix it. Okay, let's try that. So why are these not going immediately next to each other? That's what I don't understand. Oh, that's why. Because the dial diameter, that's not actually the correct diameter to use. Okay, hold on. .4. 5.4. Where is that? Yeah, it's this.
Dun 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 dun! Time!
Okay. Wall thickness times 2.
Josh, stay in the bathroom when I'm brushing my teeth.
Yes, go please. Yes.
We need to switch toothpaste because I can hardly even get the toothpaste out.
I can
of the
get it out. I
strawberry.
can get it out easily.
Okay, Joy, have Evie help you, okay?
Okay.
Knurl. This is dial diameter plus wall thickness times 2 plus part tolerance times 2. That's not right. Times 4, I think. Oh, it's actually not this. This. Wall thickness times 4. Oh, apparently I'm bad already. Is that correct? See if that breaks everything.
Ava's still brushing her teeth, and she just started.
Okay, well. Then you can watch me for a second until it's...
What is that? Can I try spinning that?
Yeah, sure.
Kind of hard to spin.
You think that one's hard to spin? Try this one. That one's even harder.
This one's easy.
What are you talking about? Okay, I'm gonna change this.
I'm actually doing it really slow,
Okay.
but it's going fast. Sorry.
Okay.
I want something easy. Hey, yeah. This is bigger.
Hold on. Okay, that's good.
I already know what I want to get.
Alright, we'll look at it in a second.
A giant Lego person.
Yeah, they don't make those.
Oh, but do they print those?
Maybe. We might.
Starting today. Ooh, what if you make a video of you printing the Lego person? Then you probably a lot of people will watch that because that's crazy cool.
Maybe. We'll have to see. If you liked the video, then like the video. If you didn't like the video, then dislike the video. Either way, tell me what you think down in the comments. If you want to see more videos about random stuff, then subscribe. You know how YouTube works. Stay Moxious.